Hello everyone, this is Dr. Sturgis, and I wanted to make a video on how to conduct a correlation analysis, as it's likely something that you'll want to do when you're working on your fire project, as it's a pretty common statistical analysis. Um, in any case, again, the purpose of this video is to show you how to run the analysis in SPSS, so this information won't directly be on the quizzes or on the exam for the course. Um, so I'm going to work with the same file that I've worked with in the other videos, the file that we used for our in-class example. So let me pull that up and we will get started. All right, so it's pretty straightforward to run your correlation analysis. Like all your analysis, they're going to be up here on the analysis menu, and then you just find correlation, and we want to bivariate. Here you pull over the variables that you're interested in, and something that'll save you some time is to put your outcome variable, your dependent variable, first on the list, and I'll show you how that saves you time here in a second. On this screen, you don't need to change anything. The only exception is this part here with two-tailed versus one-tailed test of significance. So what that refers to is that in a one-tailed test of significance, you have a directional hypothesis. You know, your hypothesis is that the relationship between what weight and non-smoking is positive or something to that effect. Here we don't have a priori hypothesis that we're working with, so we'll leave it as two-tailed, which will test for both a positive or a negative correlation. So we don't need to change anything with options or any of these other menus here. At this point, we just hit OK, and we pull up our output. And the reason you want to put your outcome variable in there first is that way you can just read down this first column here, and it's got all the information that you know, all the information that you need. So, for example, you've got weight, correlation between weight and age is here, and here's the p-value. Same thing here. Here's the correlation between weight and total family income, and here's the p-value. So for what we're interested in, we're primarily interested in this non-smoke variable, and the interpretation of it, you have to recall the way that it's coded in the data set is that non-smoking is coded as 1. So what this means is that you go from 0 to 1, so smoker to non-smoker. Since this value is positive, it means your weight goes up. So as you go from 0 to 1, your weight goes up. And since 1 is non-smoker, that means that non-smokers typically weigh more than do smokers. As you recall from the bricks that you've looked at, 0.093 is a small relationship. Remember that the thresholds are 0.1, 0.3, and 0.5. What 0.1 being small, 0.3 being moderate, and 0.5 being large. And you also recall that if we want to be more specific, we can take that correlation 0.093 and we square it. And then to make it a percentage, we multiply it by 100. So we get this figure here, 0.86%. So what this means is that knowing someone's smoking status explains 0.86% of the variation in their weight. So again, it's a significant relationship. It's statistically significant, but the magnitude of the relationship is not large. It's not explaining very much of the variation. In any case, I hope that you found this video to be useful, and if you have any questions, feel free to reach out. Take care.